Hey guys, chemistry student. So this is the second video that what I was gonna go over the section on cognitive. I know a lot of you have issues or have kind of find it confusing in terms of the 3D and 4s orbital and the confusion part. Now, and as I said in the other video, I'm gonna go over it with you. Now, the thing is this, what I do notice, and I would ask you to pay attention to it, is the following. Now, I went to the dynamic periodic table, and this is nice because you can actually see that they actually have the electrons being laid out here, right? So this will be the first shell, second shell, first shell. I know they don't show the 3D and 4D, but keep in mind, if you remember correctly, um, so if you remember correctly, the one here, uh, the one here on the bottom is, let's see, the one here on the this here is on the one that is in 4s. Okay, so as you can see, this is on 4s, and so as you can see, calcium, this is also 4s2, right? So here, this part, the 2 part here, it corresponds to 4s. So remember, as part of the first part of that lesson's video about quantum mechanical model, this will be everything in first orbits. Yep. Second, third, and fourth. So third one, even though this one it has S, P, and D, you will have it all kind of combined together. Now, so what I want you to pay attention to, and this is the part that's important. So as you look around, because this is the part where it's like 4s 3D orbital part. So you notice that it's 4s1, 4s2. Now it's 3d1. So it's 4s2, 3d1. So let's confirm that. See? 3d1, 4s2. And then go here. 3d2 now. Okay. Now this continue until this part. Now you see it's chromium. It's chromium that is, you rather fill the 3D than have the 4s. Okay. So you have the chromium. Now, in manganese, you filled up that 4s right away. And then iron, and then cobalt. Okay, so let's go back to filling the 3D orbitals now. Going back to 3D orbitals. And then copper. Oh, copper again. This is the part which fills up they rather you lose the 4s. And they rather you lose the one on 4s to fill up the 3D orbital. Right? So, in this case, if you look back at the cognitive part, so pretty much all here, it's basically what I was teaching you the other on the not this PowerPoint, in this quantum mechanical model about quantum numbers. So it's pretty much following the rules. You go with the lowest energy level first, and then you go by you try to fill out the shells. You rather have half filled shells than have empty shells or empty slots. But not coming back here. But the exception part, okay, the exception to the rule. Now over here, they say that the only exception is only those two that you see, the chromium and copper. Just like earlier when we look at the dynamic atomic model, pretty much everything would have followed the rule except chromium and copper. Okay, that is because they want to rather fill out. You want to have stability to have more of the 3D shells being filled, then you have that one shell being half filled. You rather have that. Okay. Yeah, because if you think about it, 3D, and this is the part where I'm going to plug in my document camera. Awesome. So let's see, I'm just going to draw something. So let's do it like this, okay? Chromium. Oh, it's pretty focused. So chromium, Cr. Now I'm just going to focus on the 4s 3D part. The other part, it's just like the argon, so I'm just going to ignore that part. So if you look at it, argon, the diagram, so you have at that point, okay, so you have these, let's just say that's a 3D, this is the 4s slots. I'm going to use, do I have a pencil that works in my house? I probably do, but I don't have it here right now. So I'll just use a different color, okay? Hopefully this pen works. Awesome. So in this case, if you look back at it, 4s1 and 3d5. Now, 4s1, 3d5. Remember, you always spread out the shells, right? So in this case, the reason why this works rather than you keep one of these here is because now, remember what we said on this last slide here. Go all the way to down. Okay. You want to have stability. Okay, you want the stability. And in this case, filled shells is more stable than half filled. It's better than neither. So in this case, this configuration, which is actually what happens, you have all these 6 slots are half filled. Okay, all these 6 slots are half filled. I know the previous one. So chromium is the exception. Vanadium, blah blah. Now vanadium, the thing is this. Yes, it has 3 electrons but 4s. So because in vanadium, again, so you have that 4s slot and you have this 1, 2. These are 3d, right? So in this case, now in vanadium, yes, you have a lot empty slots here, but in stability wise, this will confer the entirely filled 4s slot will confer a lot more stability than you try to lose one, and you're still gonna have one that is not filled at all. So in this case, the math ends up working out that it's much more stable for this to look like this than to try to give up that 4s to fill out here. Okay, so in this case, the same logic goes with copper. Let me close this one. So copper is the other exception, whereas you can see it drops from the 4s. They'd rather have the 4s not filled and to have the copper entirely filled. So, not 3D entirely filled. They try to have the 4s not entirely filled, but the 3D entirely filled. So let's take a look. So in this case, your copper, so again, AR 1, 2, 3, 4, 5. That's the 3D, that's the 4s. Okay. So in this case, looking here, So the copper, now the correct form looks like this. Again, you have 1, but now you have 3d10, right? So in this case, 3d10. So in this case here, if you look, yes, this is lower energy level. This is actually, yeah, this is the, yeah, this is the lower energy level. So you fill that one first. However, you should fill this one first. However, you are, in this case, having the entire, all 5 slots entirely filled. So in this case, this is the part which is cause it to be more important. That's why uh, rather than having the 4s slot filled and this one half filled, the math works out so that it's only so that you rather the 4s not filled and the 3D. And this is the only 2 exception that we need to worry about at this point. Okay. Now there's a discussion here. Also, another thing to on Cognity is that it's always should be memorized because they always ask this. Now let us do an experiment to see how this works. Now we know that chromium is exception. Do we see mobilium is an exception? Now, in this case, maybe. Okay, you notice that the 5s shell is getting filled, but then here, similar kind of deal happens. It shifts and drops down. So it's in this row you have 2 more that not getting where you sacrifice the 5s shell, and then copper you go down 1. You notice this is the Ag silver. So again, you sacrifice that, and you look here. Pretty much a lot of this. This is you sacrifice that. You didn't sacrifice the 5s. You sacrifice that. Sacrifice that. So, and this is also the fun part about chemistry, simply because if you think about it, where do we get those? Where do we usually see these like multivalence ions, right? These multivalence ion. Now I know that iron would be a +3 plus, yeah, +3 and some other ones too, but some of these multivalent ions are because of this funny electron arrangement. So in this case, if it wasn't for these exception to the rule, which at this point of the course we don't really have a full understanding yet. You learned this in 2nd and 3rd year university level when you learn quantum mechanics. So in this case, we don't have a full understanding yet, but yet we can actually appreciate it, because if it wasn't for these funny arrangements, we wouldn't see or understand that, oh, somehow this is linked with multivalence ion. Okay, but at this point, we are very comfortable to say pretty much everything on these area. This is the s block, so you have something on the s orbitals. This is the f block. You'll have not f block, p block. So everything here, you notice it's p orbitals. Okay, but now here it's on the p orbitals. And this is here, this is the D block. Okay. So I hope this part of the video will help us understand the previous question now, the previous question that we're trying to work on. Okay. A particular metal cation has this structure. So in this case, now we know that we have 3 more electrons. Okay, we have 3 more electrons. So in this case, you have 5 electrons on that end. You know that this would be an AR. Ar plus 5 more electrons. So in this case, Ar plus 5 more electrons, Ar plus 5 more electrons will be 1, 2, 3, 4, 5. It will be vanadium. Okay, it will be vanadium. So that would probably be one way to solve this problem. It's like, oh, I know that plus 3. I know that I have to have 3 more electrons. So just 1, 2, 3, 4, 5. Okay. Now in this case, the electronic structure of the vanadium, which we solved earlier, I know we kind of a little earlier we did that one because we looked it up, but it's good to have practice. So in this case, vanadium, we know that we can do if we do the shorthand. Now this one they're not asking for the shorthand. So the shorthand one? No, they didn't. Now this one they call earlier question they have a complete one. So this one I guess you can do a shorthand. So Ar. Now by Ar you just have 5 more electrons. So again, following the rule, we go with the lower electron level first, which is 4s. You fill out the 4s orbitals first. 4s. Sorry. And now you have the 3d orbitals, which have 5 slots. And then you have 3 more electrons left. So it's 1, 2, and 3. And then you're done. Okay? This is blocking. Explain why the structure of the ion could not be the structure of the neutral atom. Well, one of the simplest way is because so one of the simplest ways is because you for neutral atom you actually have 5 more electrons. You're talking about an ion which is 3 plus, you actually have 3 electron less. So in this case it will be in this case you will have it's not the same. You just have different number of electrons. Oh, by the way, I realized earlier I just draw the structure. I didn't write out in this form, so let's do that. So Ar 4s2 3d 1 2 3 3. Okay. So I hope this video helps people to kind of understand the section better about the 3d and 4s rules. Now, I hope that, make sure you continue to work with these practice questions and work on your lab, okay?